Let's begin our review of solving systems of equations. The first method we're going to use is substitution. Number 1 is y equals 3x plus 5. Number 2 is 2x minus 3y equals 6. Now in substitution we want to get one of our equations in the form y equals or x equals. This one already is. So what I'm going to do is I'm going to take 3x plus 5 and I'm going to substitute that in place of y in this other equation. So this equation becomes 2x minus 3 times 3x plus 5 equals 6. And then I'm going to solve this equation for x. So I'll be distributing that negative 3 to both of these terms. So I'll have 2x minus 9x minus 15 equals 6. Combine these like terms, negative 7x, and add the 15 to the other side. So negative 7x equals 21. Divide by the negative 7. And we get x equals negative 3. Then we're going to use x equals negative 3 and substitute that into y equals 3x plus 5 for the x term, the x value. So y equals 3 times negative 3 plus 5. So y is negative 9 plus 5, or negative 4. Then my solution will be the ordered pair, negative 3 for x, negative 4 for y. Number 2, we have 2x plus 4y equals 12, and x plus 2y equals negative 14. To solve by substitution, it looks like it'll be easiest to use the second equation and subtract 2y from both sides. So that's going to leave me x equals negative 2y minus 14, which I will substitute into the first equation for x right there. So that gives me 2 times negative 2y minus 14 plus 4y equals 12. Distribute that 2, I get negative 4y minus 28 plus 4y equals 12. Combining like terms, I get negative 28 equals 12. Now this equation is a false equation all the time. This is always false. When we get an equation that is always false in solving systems of equations, that means that the system has no solution. And if we were to graph them, we would have parallel lines. But the answer to the question, what's the solution to the system, is that there's no solution. A second method that we've learned to solve systems of equations is by elimination. And to solve by elimination, like we will on number 3, what we need to do is make it so that one of the variables has opposite coefficients. Then we add our equations together. So I will label these equation 1 and equation 2. And I can see that in the second equation I have 2x minus 3y equals 1. So if I multiply equation 1 times 3, that will give me 3x plus 3y equals 39. And that's going to allow me to add the two equations together, and the plus 3y and the minus 3y will add to 0. So that will eliminate the y's. So I have 5x equals 40. Now I can solve for x, and I get x equals 8, which I will then substitute into either equation 1 or equation 2. It doesn't matter which one. To me it looks like equation 1 will be easier, so I'm going to use equation 1. So I'll have 8 plus y equals 13. Solving for y, that gives me y equals 5. So then the solution to the system will be the ordered pair 8, 5. Our second example of solving systems by elimination oops, that should be a 2, is 5x plus 7y equals 40, and 3x plus 2y equals 12. So I'm going to need to get one of my variables to have opposite coefficients. So let's eliminate x this time since we eliminated y last time. So if I take equation 1 times 3, that's going to give me 15x plus 21y equals 120. Now I need my other x to have a negative 15. So I'll multiply equation 2 times negative 5. So that will give me negative 15x minus 10y equals negative 10. When I add those equations together, the 15x and the negative 15x cancel out. I get 11y equals 110. Solving for y gives me y equals 10. I can then sub that into either equation 1 or equation 2. It doesn't matter. I think I'll just choose equation 1. So I have 5x plus 7 times 10 equals 40. So 5x plus 70 equals 40. I'm running out of room. Subtracting 70 gives me 5x equals negative 30. Divide by 5 gives me x equals negative 6. So my solution will be the ordered pair, negative 6 for x and 10 for y. The next systems we're going to solve are nonlinear systems, and we're going to have to graph those as well as solve them algebraically. So our first system, y equals square root of x, and y equals negative 1/3 x plus 6. The square root of x is going to be that parent function that starts at 0, 0. You go over 1, up 1, over 4, up 2, and then over 9, up 3. Makes that eyebrow shape. And the other equation is a line, has a y-intercept at 6, and a slope of negative 1/3. So over 1, down 1 over 3, down 1 over 3, down 1 over 3, down 1 over 3. So there's my line. So it looks like I have a solution right here. Let's look at the algebra here. The strategy I'm going to use is to set y equal to y. So square root of x equals negative 1/3 x plus 6. Then I will go ahead and square both sides to get rid of this radical. So we get x equals, I have to FOIL the negative 1/3 x plus 6 times negative 1/3 x plus 6. That's going to be a lot of fractions. Negative 1/3 x, that's positive 1/9 x squared, and then 6 times negative 1/3 x is negative 2x, and another negative 2x, and a plus 36. So I have x equals 1/9 x squared minus 4x plus 36. Then I will subtract this x over, so I get 0 equals 1/9 x squared minus 5x plus 36. And the easiest way to deal with this fraction is to just multiply both sides of the equation by 9. I still have 0 on the left, but that gives me x squared minus 45x plus whatever 36 times 9 is. 324. Goodness gracious. I think I'm going to grab a calculator so we can use the quadratic formula on this one. I'm not quite sure. Let's see, 324. Well, maybe we could factor it. 324 divided by 9 is 36. So x and x, let's see, 36 and 9. And my inside and outside has to equal 45. Oh, good. We got it. We factored it. Yay. So x minus 36 and x minus 9, which then allows me to write the two equations, x minus 36 equals 0, x minus 9 equals 0. So x equals 36 or x equals 9. Now I also have to take these two x values and sub them into either equation 1 or equation 2 to get the y values. Equation 1 was y equals square root of x, so that's probably the one I'm going to use. So if x is 36, y would be square root of 36, so y is 6. If x is 9, y will be the square root of 9, or 3. So I have two ordered pairs, 36, 6, and 9, 3. In looking at my graph, though, I can see that I only have one solution right there at 9, 3. The other solution, 36, 6, is what we call extraneous. Remember that you can have extraneous solutions anytime you square both sides of an equation. So that happened here. So our only solution is 9, 3. Next one is y equals x squared minus 4 and y equals x minus 4. So this is a parabola and this is a line. So let's graph those. Y equals x squared minus 4 has a vertical shift down 4. So 1, 2, 3, 4, and then it goes over 1, up 1, over 2, up 4, over 3, up 9. Our line, y equals x minus 4, has a y-intercept at negative 4 and a slope of 1. Over 1, up 1, over 1, up 1, over 1, up 1, down, 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 down. So it looks like we might be intersecting in those two spots right there. Let's solve it using algebra. Again, we'll set y equal to y, so we have x squared minus 4 from our first equation equals x minus 4 from our second. This is quadratic, so let's move everything to the same side together. So we have x squared minus x, those two terms cancel, equals 0. I can factor this. There's a greatest common factor of x, so that'll be x times x minus 1 equals 0, which allows me to write two equations, x equals 0 and x minus 1 equals 0, which tells me that x equals 1. I need to sub those in. I will use equation 2, which is y equals x minus 4. So when x is 0, y equals 0 minus 4, so y is negative 4, which gives me the ordered pair 0, negative 4. And when x is 1, y equals 1 minus 4, which is negative 3. So the other ordered pair is 1, negative 3. And when you look at your graph, 0, negative 4 is right here, and 1, negative 3 is right here.